All right, so last one in the group. We want to find the temperature at which a single molecule is expected to have a certain velocity. So RMS stands for root mean squared. It's just kind of a fancy way of taking an average. Our formula is a mixture of what we saw earlier with the 3/2 and the special constant and the 1/2 mv squared from kinetic energy normally. And so, we kind of recognize pieces of this. The mv squared is still here, but the 1/2 kind of gets canceled from the other part. So on the bottom, we just have 3 times Boltzmann's constant. Now, it's important to note that this needs to be in kilograms. So we need to do that conversion first. So to find the mass in kilograms, take our molar mass, 48.05 grams, divide by that modified Avogadro's number, so 6.02 times 10 to the 26. And remember, that's going to make this into kilograms, right? So the kilograms per mole. And then again, this one has the mole -1, which are weird units, but they immediately cancel, and we get kilograms. All right, then dividing this, that's 7.9817, and it goes on, but that's enough, times 10 to the -26, and that's kilograms, which is what we needed over here. Then we have our velocity here, and everything else is a constant, so that's good. All right, so the mass, 7.9817 times 10 to the -26. The velocity is 424. By definition, it gets squared, then here over 3, and then Boltzmann's constant, which I always have to look up. So 1.38 times 10 to the -23 joules per Kelvin. Okay, so looking at these units on the top, that's going to turn into meters squared and seconds squared. So meters per second squared combines here to make newtons, and the extra meters makes that into joules. So as it turns out, all of that stuff cancels with the joules on the bottom. Then the Kelvin, because it's on the bottom of a fraction and the bottom of a fraction, it does this kind of like flip and multiply thing and turns into Kelvin. So a little bit tricky to follow there, but it does work itself out. Want to probably do these parts separately. So the bottom's probably easier. 3 times Boltzmann's constant is 4.14 still times 10 to the -23. Then on the top, this number to the 10 to the -26 times 424 times 424 again is roughly 1.43492 times 10 to the, looks like -20. Then Kelvin was all that was left over from earlier. Then to get a final answer, we want to divide those carefully in the calculator. You may need more parentheses around the bottom to make it work. But eventually you should get 346.60.